Contact force is a force that acts at the point of contact between two objects. Normal force, this would be normal force, is a support force exerted upon an object that is in contact with another stable object. Equilibrium. Equilibrium is the condition of equal balance between opposing forces, where a ray has the same strength as the weight dropping down. Newton's third law of motion. Notice that for every action there's an equal opposite reaction. As ray is picking up the weight. Newton's second law of motion. The Newton's second law of motion is the acceleration of objects is dependent upon two variables: the net force acting upon the object of the mass. The acceleration of an object depends directly upon the net force acting upon the object and is inversely upon the mass of the object. Or he's picking it up again, base. Okay. Right.
Alright.
One.
Okay, we're going to talk about inertia as Alfredo picks up the weight. It's a property of matter by which it continues in its existing state of rest or uniform motion in a straight line unless that state is changed by an external force. So as he's holding it up, without Alfredo holding it up, the weight will just drop. And it's the continual force. And so I'm using Newton's first law of motion. Object stays at rest, is in motion at the same speed in the same direction unless acted on by an unbalanced force. So Alfredo's holding it up, and like I said, just like inertia. This is called Newton's law of inertia, it's nicknamed. And so tension, and see all the tension he has right here as he drops the way down. It describes easily it can be a means of a string or a cable right here, or of a similar one-dimensional continuous object, or by each end of a rod. But tension can be described as action-reaction pair of forces acting at each end of said elements, and this guy has a lot of tension right now. Alright, so friction force is as his feet push against the ground, it helps a lot in bench, and it's a force of resisting a relative motion of solid surfaces, fluid layers, and material elements sliding against one another right there. And so the applied force, as he drops it way down again, he wraps it again, is a force that has been applied to an object by another person or object. So there's a lot of applied force there. And
One.
You know, we're just doing take two.
so we're doing take two. Alright. So
Take two.
acceleration. Poor guy's tired. Alright, so acceleration is the rate of change whenever he takes off. Alright, so rate of change of velocity of an object with respect to time. So I believe it's been 2 seconds. This kid's fast. Look at how fast that kid's going. Zoom in. Alright, so that's velocity. And so next we're doing air resistance. And I have a little definition right there. Air resistance or resistance of the air to him. As you can see, he has a lot of air resistance. And the velocity is the direction and speed that he's going. So this is south, he's going east right now. There's velocity. Okay, so the speed he's going is like 100 miles per hour. This guy's freaking animal. Look at him, just dead sprinting it. God, he's gonna get like a 41. Alright, so the instantaneous speed right here. Look, watch this part. He's just gonna take off. I already know. Look, there he goes. Look at that. Instantaneous speed is the speed at any given moment. So look at how fast he's going. Alright, so now, and so he's finishing it. Look at this instantaneous speed. He's almost done. There he is. Alright, so the total distance that this guy ran was 400 meters. Well, more like a mile. How many takes we did. So total distance, the displacement is actually 0 because he stopped right there. So the displacement, even though he ran this whole place, he just stopped right there. So it's an overall change of position. So he just, no change of position from where he started at. So it was worthless, Fredo. You got 0 displacement.
No.
0.
You good?
Alright, so we're just using this object in there for demonstration purposes. Obviously it's a 3-prong theory, but that's irrelevant. So it's inside that container as he spins it. And so a centripetal force can't talk is it's so as it's following a curved path, what makes it go on that curved path is the thing that's acting inwardly, which is his hand. And so that's a centripetal force. It makes it go inwardly. And so a centrifugal force is an apparent that force that acts on the outward on the body moving around the center, arising from the body's inertia. And so that three-prong, if we somehow zoom it on, which we can't zoom it in, it's making three-prong go outwards.
Hey, brother Jimmy.
But it's so it's making three-prong. Yeah, we're at trying to hold it right there, Josh.
Stop, Josh.
Okay, so as it's moving in a circle, it wants to go out because, as you can see, if you let go of it, you let it go that way. Yeah, there you go. So that's centrifugal force because the inertia makes it, in moving in a direction, it just wants to go.
If I let go of it, we just want to go in a straight line.
So for our last word, we're doing free fall, and it's a really tough word. It's hard to understand. So we're a body where the only force where gravity is the only force acting upon it. So as you can see, it's free fall. I think there's gonna be a little bit of air resistance, but you get the idea. So that's free fall.